Hi students, in this class we will learn how to draw free body diagram in different situations. Now for example, object is placed on a horizontal surface. You assume mass of object is taken as a m. It is placed on a horizontal surface. First we should identify the how many forces are acting on the object. Here this object is in contact with only horizontal surface. That's why only one contact force is acting, and another one its weight is acting vertically downward direction. So wherever you place the object, its weight is acting vertically downward direction. So weight of the object is acting downward direction, and normal reaction exerted by the ground is acting in a upward direction. This is the normal reaction exerted by the ground. It is acting in a upward direction. If you take free body diagram, in this free body diagram, you take this is a mass of the object here. Its weight acting downward direction W, and normal reaction acting in a upward direction. This is free body diagram in this case. Now suppose one object is placed against a vertical wall. To keep this particle, this object against a vertical wall, we must exert some force in this direction. Then only the block is at rest against a vertical wall. In this case, its weight is acting downward direction. Weight of this object is acting downward direction. Now suppose the surface is a rough surface, then frictional force is acting in a upward direction against the object. So frictional force acting in this direction, force of friction. If smooth surface, no frictional force acting. If surface is rough surface, then only frictional force acting in upward direction. And one more force, it's a normal reaction. Normal reaction exerted by the wall on the object acting like this. In this direction, normal reaction is acting. Then a normal reaction, angle between normal reaction and surface is equal to 90 degree. If you take this object, on this object, number of forces are acting. One is applied force acting in this direction, F. Second one is normal reaction is acting in this direction. Weight of the object is acting vertically downward direction, weight. And one more frictional force acting in upward direction. So this is the free body diagram of this object. Next, come to third case. Here, object is placed on a inclined plane. Here, this object having only one contact, that is with the inclined surface. That's why here only one contact force is acting. So that is a normal reaction. Normal reaction acting perpendicular to surface which are in contact. So this is the direction of the normal reaction on this block. Normal reaction acting in this direction. And weight of the object is acting vertically downward direction. From the center of the object to weight acting downward direction, W. These two forces are acting. Here suppose the surface is a rough surface. In case of rough surface, frictional force is acting in this direction. If the surface is smooth surface, no frictional force is acting. Surface is rough surface, then only frictional force we have to consider. In this case, free body diagram, you take this is the object. On this object, weight acting downward direction, W, and normal reaction not balance weight, it is acting in this direction, making certain angle like normal reaction acting. And frictional force is also acting not along the horizontal direction. Frictional force acting like this. In this direction, friction is acting. This is free body diagram. Suppose here forces are not acting along horizontal and vertical direction, then the forces we must resolve into components. So we will learn component method in next class. Come to here now. A rod or a stick, you take whatever it may be, of mass capital M is placed against a vertical wall. How many forces are acting? In this case, if rod is placed here, its weight is acting downward direction. From the center of the rod, its weight acting downward direction, W. This rod having two contacts, so that's why two forces will act, two normal reactions will act. One is normal reaction. In this case, normal reaction always acting perpendicular to contact surface. So this is the one normal reaction. Take it as N1. This normal reaction is taken as N1. And one more contact is here. That's why another normal reaction acting here. This normal reaction is taken as N2. Two normal reactions are acting like this. If you draw free body diagram for this rod, on this rod, how many forces are acting? One is weight acting downward direction, W, and the second one, normal reaction N1. N1 is acting vertical upward direction, and N2 is acting along the horizontal direction. This is the free body diagram of this rod. Forces acting like this. And next, here, one rod is placed on steps. Here, these are taken as the steps. Here, two contacts are there. That's why two normal reactions will act. Normal reaction always acting perpendicular to contact surface. That's why here normal reaction acting like this. This is one normal reaction. Here also another normal reaction acting like this. The angle between normal reaction and the surface is equal to 90 degree. Like normal reaction will act now. From the contact surface, this point of surface. And its weight is acting vertically downward direction. Weight of the rod W. In this case, you draw free body diagram here. Weight of the object is acting downward direction, and here if you observe two normal reactions, this is taken as N2 and this one is taken as N1. Now these two are acting almost both are parallel, that's why both are in same direction. This is N1 and another one is taken as N2. They are acting like this, two normal reactions. Come to this one. Here, one sphere or one circle is placed on a horizontal surface. Mass of the sphere or circle is taken as a capital M. In this case, here the circle has only one contact sphere. So, only one normal reaction acting. Here it's weight acting vertically downward direction. Weight always act from the center of the circle. So, center of the sphere to weight acting vertically downward direction, W, and normal reaction acting from the contact surface. From the contact surface, normal reaction acting upward direction like this. This is the normal reaction. You draw free body diagram for this one. Only two forces are acting. One is this weight downward direction, and another one is normal reaction that is acting in vertical upward direction. These are the free body diagram. And come to this one. Sphere is placed in a V-shaped groove. In this case, how to find it? Now, wherever you place object, its weight acting vertically downward direction. So, this is the weight W. Next. Here two points are there, two contact points. Suppose you take this contact point is taken as A and this contact point is taken as B. Here how to draw normal reaction? Then a normal reaction, making an angle 90 degrees with the surface. In case of spherical bodies, normal reaction, you join the, this is taken as a point of contact and this is the center. The line joining point of contact and center of the sphere, this gives the direction of normal reaction. So here NA will act in this direction. And the sphere having one more contact here, again you join. So from the point of contact to center of the sphere, okay, the point of contact to center of the sphere, it gives the another normal reaction. This is taken as NB. Like two normal reactions are acting on the sphere. You draw free body diagram. In case of free body diagram, its weight acting downward direction W, and one normal reaction acting like this NA, and another normal reaction acting like this. This is ND. These are the free body diagrams in different situations. Next, we see in different model. Next cases now. Here you assume mass of the block is taken as capital M and the mass of the rod is taken as small m. First, for the block, in this case, block weight acting vertically downward direction W. Normal reaction acting on the block in upward direction. Here one normal reaction. This is taken as N1, and the block is in contact with the rod. So one more normal reaction acting on the block. Here this normal reaction is perpendicular. So the direction of normal reaction is like this. For every action there is an equal and opposite reaction. The normal reaction exerted by the block on the rod is equal to normal reaction exerted by the rod on the block. So these two are acting like this. On the block acting like this, on the rod normal reaction acting like this. So this normal reaction is taken as N2. This normal reaction making an angle 90 degrees with the rod here. On this rod, one more normal reaction acting because of ground. So this is normal reaction. This normal reaction is taken as N3. And weight of the rod is acting downward direction from the center of the rod. From the center of the rod, weight of the rod W acting in downward direction, that is equal to small m a. If you take free body diagram, in this is taken as a object of mass capital M. On this M, weight is acting downward direction W, that is equal to mg capital M, mg, and normal reaction, one is acting in this direction, that is N1, and another normal reaction acting downward direction. So this is another normal reaction, that is N2. These are the forces are acting on the capital M. Same free body diagram for the rod. Mass of the rod is taken as small m. On this rod, its weight acting downward direction W, that is equal to small mg, and normal reaction exerted by the surface acting upward direction. So vertically upward direction, N3 will act. Same normal reaction exerted by the block making certain angle. So acting like this, opposite direction to this one. So this is the direction of N2. That is free body diagram of the rod. Next, come to here. Now in this case, one sphere is there on the sphere one rod is placed. Assume mass of the sphere is capital M and mass of the rod is taken as small m. Mass of the rod small m. If you observe here, sphere having three contact points, 1, 2, 3. So, three normal reactions acting on the sphere. If you observe the rod having only two contact points, rod having two normal forces or two contact forces. In addition to those forces, weight always acting downward direction. So, weight of this sphere is acting downward direction. W is equal to capital Mg. Next, normal reaction. Now, from the point of contact to center of the circle, this is the direction of the normal reaction. Take it as N1, N1. And here, this is point of contact and this is the center of the circle. So, this is taken as N2. And one more normal reaction. This is the contact point. From the contact point to center of the sphere, this is the direction of N3. Now here, this sphere also exerting normal reaction on the rod. So on the rod, normal reaction acting in this direction. This is N3. And this rod is in contact with horizontal surface. This horizontal surface exerting normal reaction N4. And weight of the rod acting downward direction. So from the center of the rod, its weight acting downward direction, small mg. So first we draw free body diagram for sphere. Fbd of sphere. This is sphere of mass capital M. On the sphere, weight acting downward direction mg. Normal reaction N1 is acting in this direction. In this direction N2 is acting and N3 is acting like this. In this direction N3 is acting. This is the direction of N3. Same free body diagram of the rod, Fbd of the rod. Mass of the rod taken as small m. Its weight acting downward direction. Normal reactions due to background upward direction. This is N4. And because of sphere, normal reaction acting like this. This is N3. This is free body diagram of the rod. Next, come to here. So sphere is placed on the steps. In this case, sphere having two contacts here and here. So two contact force acting on the sphere. This is contact point and this is the center of the sphere. The line joining these two. This is the direction of one normal reaction N1. And this is point of contact. Point of contact to center of the sphere. This is the N2 direction. From the center only it will pass. That is N2 direction. In addition to those two, weight of the rod acting, weight of the sphere acting downward direction, that is mg. So if you draw free body diagram for this one, this mass is taken as capital M. Weight is in downward direction. And normal reaction N1 acting in this direction and N2 acting like this. Come to this one. Here, this surface, this box having two contact points. So two contacts, two normal reactions will act. One normal reaction is acting like this, perpendicular to the surface. This is taken as N1 and one more normal reaction acting like this perpendicular to this surface and passing through the center, that is taken as N2. N1 and N2 two contacts are there. So you draw free body diagram for the mass on the box is taken as M. Its weight is acting downward direction Mg, and one normal reaction is acting in this direction N1, and another normal reaction is acting in this direction. This one is taken as a N2. These are free body diagrams for next. Here, three blocks of masses M1, M2, M3 are kept in contact and horizontally pushing with a force F. Then draw free body diagram for M1, M2, M3. If you observe here, three blocks, its weights are acting vertically downward direction. For first block, its weight acting M1G downward direction. Second block weight M2G is acting downward direction, and third block weight is also acting downward direction. And normal reactions are acting vertically upward direction. So this block, on this block, because of flow, normal reaction acting in upward direction, take it as M1. Here on this block, normal reaction N2 is acting in upward direction. On this block, normal reaction N3 is acting upward direction. Three normal reactions are acting upward direction. And if you observe here, this M1 block is in contact with M2. That's why there is a contact force between M1 and M2 will act. So here this contact force is called normal reaction. Normal reaction always push a body, pushing. That's why this normal reaction acting on M1 in this direction, on M2 in this direction. This is normal reaction between block 1 and 2. So represented with N12. In same manner, there is a contact force between normal reaction between 2 and 3. On 3 acting like this, on 2 acting in this direction. So this is N23. If you write separately free body diagram of, you take M1. First we are drawing for M1. This is taken as a M1 of mass. On this, its weight acting vertically downward direction. That is M1 into G. On this, normal reaction is acting in a upward direction. This is N1. And one more normal reaction because of block 2 is acting in this direction. This is N12. And one more force is acting, that is applied force. Applied force is acting in this direction F. So these are the forces acting on the block M1. Similarly, on M2, free body diagram for block M2. This block M2. Its weight acting vertically downward direction M2 block. On M2 block, two normal reactions are acting. One is by the ground and one is this is surface. This is N2 and the first block. So every action there is an equal and opposite reaction. That's why for this opposite direction on N2, reaction force is acting in this direction N12. Next, come to third body M3. On M3, M3G weight acting downward direction. M3 into G. And here only one normal reaction acting because of block and another normal reaction acting in upward direction. So upward direction normal reaction is taken as N3 and normal reaction between 2 and 3 acting in this direction. Now if you observe here on M2, one more normal reaction acting, that is because of M3, that normal reaction is acting in this direction, that is N23. So these are the forces acting on the three blocks when the three blocks are kept on a smooth horizontal surface. Next, here three blocks M1, M2, M3 are connected by a string. Here two strings are there. Mass of the strings are negligible. Here strings are massless strings, and three blocks are kept on a smooth surface. And the first block is pulling with force F. Then what is the free body diagram of M1, M2 and M3? Now in this case, here string is there. Whenever you put some tightness is developed in the strings, the tightness developed in the string is called tension. Tension is a pulling force, not a pushing force. Means it acts away from the object. That's why in the string some tension will develop. This tension try to pull M1 in this direction and try to pull M2 in this direction. So this is the T1 tension direction. On this block, here another string is there. In the string, tension T2 will develop. The tension T2 try to M3 in this direction and try to M2 in this direction. This is tension direction. So tension, two tensions T1 and T2 are acting. Those are the directions. Next, weight of the blocks M3G, M2G, M1G acting downward direction. Because of the surface, normal reactions are acting in a upward direction. So free body diagram for first we are drawing for M3. So free body diagram of M3. Take it as M3. On M3, weight acting downward direction. M3G. Normal reaction acting upward direction. This is N3 and tension is pulling in this direction, that is T2. So this is free body diagram of M3. Similarly, free body diagram of M2. On M2, tension T1 try to pull in this direction, T1, and T2 try to pull in this direction. These two are acting opposite direction tensions, and a normal reaction acting on the block in upward direction N2, and weight of the block M2G is acting downward direction. This is the free body diagram for the second body M2. And next for M1. On M1, applied force F is acting in this direction. This is applied force F. Weight acting downward direction M1G, and its normal reaction acting upward direction, that is N1, and one more force, that is tension, is acting in this direction T1. So this is the free body diagram of M1. In this case, two blocks M1 and M2 are connected by a string passed over a pulley. Here we are considering mass of the pulley and mass of the strings are negligible. Weightless pulley is weightless, and strings are also taken as light in weight. No need to consider mass of these two. In this case, string passes over the pulley. In string, tension will develop. This tension always try to pull the body, it never pushes the body. Here only one string is there, only one tension will develop. This tension try to pull upward direction M1 block. Tension T is try to pull M2 block is also in upward direction. This tension try to pull the pulley in downward direction. This tension try to pull the pulley in downward direction. This pulley here. On this clamp, how much force is acting? Here, these two forces are acting downward direction. That's why same amount of force is acting, some force or thrust T plus T, that is 2T acting on the cloth in this direction. Draw free body diagram for M2. Its M2 weight is acting downward direction. M1 weight is also acting downward direction. So free body diagram for M1 first. Fbd of first we are drawing M1. Take it as M1. Its tension is acting upward direction. Tension. Its weight is acting downward direction, vertically downward direction. Only these two forces are acting. In this case, if M1 is greater than M2, then M1 is moving downward direction and M2 is going upward direction with certain acceleration. So this acceleration is taken as A. Both blocks are moving with certain acceleration taken as A. So then resultant acceleration is acting downward direction on this block. Come to second block M2. For M2 block, its weight acting downward direction M2 into G. On this block, tension is acting upward direction. Its acceleration is along the vertically upward direction. So acting in this direction, acceleration. That is free body diagram. Next, come to here. In this case, two blocks are connected by a string. Only one string is connected, that's why only one tension developed. Tension always try to pull the body. So here tension is acting in this direction. In this block, tension acting like this. In addition to that, for this body, weight is acting downward direction, its weight is also acting downward direction. But this block is kept on the surface. Because of the surface, normal reaction is acting on M2 vertically upward direction. Normal reaction acting on M2. So if you draw free body diagram for first we are drawing for the block M1. Assume this is M1. Its weight acting downward direction. M1G. And the tension is acting upward direction, but this block is moving downward direction because the surface is a smooth surface, that's why the block is moving downward direction with certain acceleration here. Next, come to block M2. This M2 block. Weight acting downward direction. M2G. Its normal reaction is acting upward direction. This is normal reaction. And tension is acting towards right. This is the tension. So block is in vertical equilibrium and moving along the horizontal direction. So acceleration is acting in this direction. That is the acceleration of the block. Here, this is called wedge and this is mass. M mass is placed on the wedge. In this case, here if you observe, wedge is contact with the floor under this block. Because of this floor, one normal reaction acting, that is in upward direction. This is the normal reaction direction on the wedge N1. And another normal reaction because of this block is acting perpendicular to the surface. This is N2. For every action there is an equal and opposite reaction. Same normal reaction acting on the block in this direction. This is N2 direction on the block. In addition to this, weight of the capital M is acting downward direction, weight of small m is also acting downward direction. So these are the major forces acting on the blocks. You take a free body diagram of capital M. Here all surfaces are taken as smooth for capital M. Weight of the capital M is acting downward direction, capital MG. Normal reaction N1 acting in this direction and another normal reaction N2 is acting in this direction. And here because of smooth surfaces this capital M is moving along a horizontal direction with an acceleration A. Clear? Next, come to small m. Small m, normal reaction on this is acting, making 90 degrees with the surface. So N2 acting like this, and its weight is acting downward direction, small mv. This block, because of resultant force, it is moving down along the inclined plane with a certain acceleration. So this block acceleration is taken as N1 capital M. Then you take acceleration of this one is taken as A2 is in this direction. Here, in addition to this A2, some pseudo force is also acting in this direction. Pseudo force, I will explain about it. So later, so pseudo force MA1 is acting in this direction. This is the third force.